Name each figure. We have 5 shapes, and not only are they shapes, they're solids. They're 3D shapes, 3 dimensions. So I have to name each of them. There's several types, but I think we're going to look at 3 main types here. If they end up in a point at the very top, imagine that's a 3D shape, it's a pyramid of some type. If they go straight up and create some type of shape, as you can see poorly drawn there, that is a prism. And then there's the ones that are round, like that guy and that guy, and we'll end up doing those in a second. Now, if it's a pyramid or a prism, you are going to name it by saying the name of the base and then pyramid, or the name of the base and then a prism. So if it's an octagon turning into a pyramid, it's an octagonal pyramid. If it's a pentagon turning into a prism, it's a pentagonal prism. So we're going to name all 5 of these based off of that information. I'll leave that there. I think I won't need a ton of space. What we have here is a prism because all of these go up and create a base on the bottom and a base on the top. The base on the bottom and on top is a pentagon. So this is a pentagonal prism, which I think I accidentally said a second ago. But you know what? Who needs to repeat itself? Pentagonal, not to be mixed up with pentatonics. Oh, a cappella group. All right, we have a pyramid, like you see here. That is a triangle on the bottom, so that is a triangular pyramid. And this is neither pyramid nor prism. It's a ball. What's that called? That's a sphere. If you don't know what a sphere is, then why are you in this course? Why are you taking it? Why are you watching these videos? Now, this is probably the weirdest looking one. All right, what you see is you do see something that is prismic in nature, but it's off to its side. It's actually tilted up sideways. See, it looks like this guy over here, the base is on the bottom and the base is on the top. In this case, the base is on the side and the side. And the bases are actually trapezoids. So this is a trapezoidal prism. You just have to pretend it's on its side. The hardest one of all of them is this last guy right here, and it's called a cone. Well, that's it. We named each figure. And again, you're looking at naming it the type of base shape it is, and then either pyramid or a prism, unless you have a sphere or unless you have a cone. And I guess anything that would be like these two would be a semi-sphere, which is a half. But all of them otherwise would be one of these. So yeah, these are your solids. Find the volume. What we have here is we have a cylinder. Now I'm actually going to use the volume of a cylinder find the volume. What we have here is a cylinder. Now, this is a geometry course, and I'm assuming that if you're in this course, you have already taken 8th grade math, or maybe you're in 8th grade right now. But the volume of a cylinder is usually taught somewhere in 8th grade or before it. And it's given to you by pi r squared h. Now, where this formula comes from, pi r squared is the area of the circle. All right. Since this is a cylinder, the bases are circles. The h is the height. So it's basically you're saying, let's just pretend like this circle is like a pizza, and h represents how many pizzas you're stacking up, and you're just multiplying all of them together. So all of this is connected. Now it's just a matter of doing some unpleasant math. Now pi is the number pi, 3.1459, blah, 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 blah. R is the radius. 8 is also a radius. If it was going all the way across the circle, it would be the diameter. But since it's from the center to the outside, 8 is the radius. Oh, happy day. 7 is also just the height. Oh, happy day for this one. So it's just a matter of typing out into your calculator pi times 8 squared times 7. So I did that. I went off to the side and I got 1,407.4335. So I'll leave it at 0.43. Now, what you don't want to forget is your unit. This is volume and it gives you kilometers. So you are going to use cubic kilometers. Area is measured in square units. Regular old distance, regular old length and width are measured in kilometers, feet, whatever. But this is volume and this is a 3D shape. So you are using three-dimensional units, kilometers cubed. But that's it right there. That's the volume of a cylinder. Nothing crazy, something I'm sure you've seen before. Find the volume of this 3D shape right there. All right, so this is strange. What we have is a prism because whatever your base is on the bottom is also the same on top. So let's go with that first. The volume of any prism, whether it's a cube or something crazy like this, a hexagonal prism, is going to be the area of the base, which we denote by capital B, times the height. Okay, the area of the base times the height. Now, the base is a regular hexagon. Okay, so if we were to break this down further and create a new formula, the volume is going to be 1/2 times the apothem times the perimeter and then times h over here. So the volume of a hexagonal prism the volume of a hexagonal prism is 1/2 times the apothem times the pyramid times the h. Now, if you're like, what the heck's a possum? Isn't that an animal that only comes out at night? No, that's a possum. An apothem is the length that connects the center of whatever regular polygon you have to the middle of the side of the polygon. It's basically like a perpendicular bisector that connects to the center. So the apothem in this case is 3.5 feet. So if I wanted to find the volume of this, it's 1/2 times the apothem is 3.5 times the perimeter. Now what we have is we have a hexagon, which means there's 6 sides. All of these sides are 4 feet. So the perimeter is going to be 4 feet 6 times. So that's 4, not 0.4 times 6. Now we're going to multiply that to the height, which appears to be 3 feet. Now I'm not even going to pretend to try to do this in my head, although it's possible. I'm just going to go off to the side and type it all in my calculator. And Mr. Calculator says 126. Now my unit of measure is feet. So since we're dealing with volume, we're going to make sure we say cubic feet. Remember, when it's volume, it's cubic units. And in this case, we get a pretty nice number because the numbers that they gave us weren't so bad. But the volume of any prism is the area of the base times the height. We were able to break it down a little bit further since the bases were regular polygons. Oof, so many things that I have to say. Just like my words get jumbled up. But there you go, 126. Find the volume of this shape right here. Now, what we have, and what's going to be difficult to view, is we have a triangular prism. Now, usually we view a prism as something that stands up like this. Well, what if I connected these and made it look like that? Now I have myself a triangular prism. And so this guy is that guy. So if I were to turn this into that, if I were to take this and kind of tilt this over sideways, I would see that this has a height of 3. That would be my height. It has a side length right here appears to be 3. You appear to be 4. And you appear to be 5. Okay. Now, Why does all this matter? Well, the volume is going to be the area of the base times the height. Okay. Now, this is a triangle. Okay. So the area of this triangle, I'm going to view from here. Okay. If this is a triangle, I'm going to replace area of base with what the area of a triangle is. 1/2 times base times height. Now, remember, the height that I'm looking for is the height of the triangle. The height that I want for here is the height of my, we'll say P for prism. Okay, so let's just make sure that when we do this, we're mainly focusing on just the triangle. So 1/2 of base times height of a triangle. So I'm looking at this triangle. This triangle, if I were to take this and stand this up like so, this triangle would have a base of 3, a height of 4, and this hypotenuse of 5. Which one of these don't I need? The 5. So if I were looking at the triangle, it's 1/2 base, which is 3, times height, which is 4. So that takes care of my area of the triangle part. Now the height of my prism goes back to the picture that I drew over here, which is also 3. So I should be able to do this in my head. 1/2 of 3 times 4 is going to be 1/2 of 12, which is 6, and 6 times 3 is 18. That's supposed to be an 8. Now, the unit that I have here is feet. So I'm going to make sure that I say feet cubed, because this is volume, and volume is measured in cubic units. But there you have it. The volume of a triangular prism is 18 cubic feet in this case. Done. Find the volume of this shape right here. What I have is a trapezoidal prism. But the trapezoidal prism doesn't quite look like a prism, because usually when you think of a prism, you think that the base, it has to be like on top and on the bottom as well, and here it's not. Well, if you were just to imagine that this is laying flat on its side, right? And I know my picture is not going to look great at all. I'm just going to try my best. So there's the top. Dot 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 dot. Ugh, you get the idea. Trapezoid on the top, trapezoid on the bottom, prism part. If I were to take this and lean this flat and fall this down, I would have this guy be 5. That's a 5 right there. You would be from top to bottom. You would be 4.3. So that is the height of the trapezoid. The height of the actual prism is 4. The small part on top is 3, and the large part on the bottom is 8. So I have a prism with that information. The bases are trapezoids, and the trapezoidal information is a height of 4.3, a top of 3, and a bottom of 8. Okay. It also gives me like this slant looking thing of 5. I don't think that will matter. And then the 4 is the height of the trapezoid. So let's put a formula together. The formula, and this is a prism, and the formula for any prism is the area of the base times the height of the prism itself. Okay. Now what I want to do is I want to remind myself of what the base is. It's a trapezoid. And the area of a trapezoid is 1/2 times the base of the trapezoid, in parentheses, base sub 1 plus base sub 2, close it, height of the trapezoid. Now I'm going to put height of the trapezoid right there so you can see it's the height of the trapezoid. Some teachers might put this as 1/2 height and then the base, It doesn't really matter. In fact, that's what I should have done, but I accidentally misspoke and started drawing out the B, and I just kind of went with it. Now, that's going to be multiplied to the height of the prism. Okay, so I will put that there. Unfortunately, I have to get rid of my terrible, terrible, terrible drawing. So I just have to remember that when I'm talking about the red here, I'm talking about just the trapezoid. And when I'm going to ask myself for the height of the prism, it's 4 because, again, if I were to lay this flat, it would be 4 meters tall. So let's put this all together. V equals 1/2. Now, it doesn't matter which one's which or your base of the trapezoid. So I'll call base sub 1 3 and base sub 2 8. Again, doesn't really matter. The height of the trapezoid is 4.3. And the height of the prism is 4. So I can't do this in my head, so I'm going to go off to the side and figure out what this is. The old Apple Watch says it's 94.6. Now, this is volume, and the units are meters, so I'm going to make sure that I say meters cubed because it's volume. But that's a trapezoidal prism, and you find the volume of a trapezoidal prism by using this formula, or you could just jump straight to that formula, whatever floats your boat, whatever tickles your pickle. But that's what I got for this one, 94.6. Baby. Find the volume. What we have here is a cone. Now, if you're taking this geometry course, chances are you're in high school. Maybe you're in 8th grade. Maybe you're in 7th if you're that good. But at some point, you've probably been asked to find the volume of a cone. Whether you have this formula memorized or not, I do, so let me take care of you. The volume of a cone is 1/3 pi r squared h. Okay. Now, if you're looking at this, by the way, and you're like, wow, that's awfully the same as a cylinder. It is because a cone is a cylinder with a bunch of sides hacked off. That's why it's 1/3 pi r squared h. It literally would take you 3 of these to fill up a cylinder of the same exact dimensions. That's for a different day. Now, what I have here is 1/3 pi r squared h. What I have is I have my height. My height is 18. What I don't have is my radius. This 18, it has to do with my diameter. So I don't care about 18. I care about half of it, which is 9. So what I do is I take those numbers, I plug it into my formula. V equals 1/3 pi 9 squared h, which is 18. I have no clue what that is. Pi is a nightmare anyway, so I'm going to go off to the side and I'm going to ask Siri what it is. And she says 1,526 point... Uh-oh, I lost it. 8140, so I'll do 814. All right. Volume, miles. So I'm going to make sure I call it miles cubed. Okay, because volume is always measured in cubic units. So again, this is something very standard for a 7th or 8th grade class, depending on what state you live in. In 8th grade, you do cones, or in Pennsylvania, you do cones in 8th grade, and that's where I live at the Commonwealth. So there you have it, pretty easy. Identify each solid given its net. Now, a net is basically an unwrapped version of a solid figure. For example, if I were to take a cylinder like so, pretend that's a can of soup, a nice delicious can of soup, and if I were to unwrap this and kind of cut this part out, I would have myself a nice little circle. If I were to cut down here and wrap it out or unwrap it, I would have myself a rectangle. And keep in mind, there is an invisible circle here that you really can't see. If I were to pull that down, I would have myself another circle. So that is a net of a cylinder. Okay. This guy, I know what you're thinking. You're like, that's a star. No, it ain't. That's a pentagonal prism or a pentagonal pyramid. Oh, that was a close one. Prism would be wrong. Pentagonal pyramid. because the one base is a pentagon. And if you were to take all of these triangles and fold them up, they would end up being a point, thus making your pyramid. This guy, if you were to take this half circle looking thing and wrap it around that circle here, you would get yourself a cone. Okay, and if I were to take this guy, fold it up, take this guy, fold it up, and wrap these around, I would have a rectangular prism. So back in the day when I taught 8th grade, I was forced to teach this to the students, and it's hard to visualize 3D objects on a 2D space, which is what I'm doing here. And I'm sure you can find 1,000 YouTube videos that show you what this looks like, what nets look like using wonderful animation. I'm not about that. I just use computers and simple stuff. I'm a simple man with simple needs. Copy the measurements onto the net. A net is basically, if I were to take this picture, this guy right here, and take a bunch of scissors and just cut out the pentagon on the top and cut out the pentagon on the bottom and kind of cut these and fold these around, that would be the net of it. Okay, it's a flattened version of a 3D shape. My job is to turn that into that. Well, what I see first is probably the grossest thing. This is the apothem. Now, the apothem is essentially the radius of a regular polygon. So I'm going to put a dot right in the center right there and have it go to one of the sides right there, draw my 90-degree angle, and that is my 8.9. It appears to me that each side of the pentagon is 13. And if you really wanted to go crazy, so are you, and so are you, and you're 13, and you're 13, and you're 13, and you're 13, and 13, and 13, and 13, 13, 13, 13, 13, 13, 13. But I'm not going to do that. That is the height. We'll call it 5, which means you're 5, so is you, so is you, so is you, so is you. Okay, but that's me copying the measurements onto the net. Bada bing! Copy the measurements onto the net. All right, what I have here is I have a square pyramid, and I'm taking this apart. And basically, if I were to take a scissors and just cut that up at the very top, and all the triangles were to kind of fall down to the side, that's the picture I would get. So let's draw the measurements. That 20 and that 20 represents the side of this square. So I will just say that you're 20, and I'll mark all of these the exact same, because why the heck not? That 26 belongs to the height of a triangle. So I'm going to put a 90-degree thing right there. I'm going to call you 26. Now that 26 has a name, and it's called slant height. Whenever you have a cone or a pyramid and you're probably being asked to find a volume, the slant height is like the height of the diagonal side of whatever shape you're dealing with. Now, what that looks like flat is the height of a triangle in this case. But that's all I had to do here. Copy the measurements onto the net. Dunzo funzo. Oh, these are not fun. Find the lateral area and surface area. First off, what's the difference between the two? The lateral area is basically the area of the sides, not including the bases. So first off, you have to make sure that your shape is sitting exactly the way it has to. And lateral area would be like, well, let's find the area of a box if I were to take off the top and the bottom, and we only care about the sides. So in this case, the lateral area is going to be that rectangle, and that rectangle in the back. The surface area is all of the sides. So in this case, the rectangle, the rectangle, the rectangle, the triangle on the top, and the same exact triangle on the bottom. Now, if you wanted to do it that way, or if you wanted to split everything apart and be like, all right, well, then the lateral area is, let's find the area of you plus the area of you plus the area of you. Absolutely nothing wrong with that. Nothing wrong at all. But if we want to save a little bit of time, there are formulas for prisms. Now, that's supposed to be a straight line, and I failed miserably. Let's do the lateral area first, okay? And the formula for the lateral area for any prism is going to be, and I'll use L for lateral, the perimeter of the base times the height. Okay, the perimeter of the base times the height of the shape. So in my case, the lateral area is going to be 8 plus 6, which is 14, plus 10, which is 24. The height of my shape is 4. And so the lateral area for this guy is 96. I can handle the math on this one. Now, this is kilometers, and we're talking about area. So the lateral area is kilometers squared, because with area, you square your units. That is the lateral area. Now, what I want to do is I want to find the total surface area of my shape here. Okay, so the total surface area, which I'll call SA, and I know what you're thinking, hey, that's what I call my friends. I call them SA. No, not for this. Surface area is going to equal 2 times the area of the base. We've seen that capital B when we've done, it's volume before, plus the perimeter times the height. All right, so first things first, we have a triangle for a base. Okay, so if I wanted to find the area of the base, I'm looking at my triangle, 1/2 times base times height. If I were looking at this triangle right here, it would sit perfectly fine on top of that 8. So 1/2 of base would be 1/2 of 8 times height would be 6. So 1/2 of 8 is 4. 4 times 6 is 24. Okay, so each base has an area of 24. So my surface area is going to be 2 times 24 plus perimeter times height. Well, wait a minute. I did that already. I got 96. Well, let's not overcomplicate things. 2 times 24 is 48. And 48 plus 96 is 144. A nice number. Again, we're dealing with area, so our units of measure are going to be square kilometers. Okay? Again, with these guys, you can split it up in different parts and add up each side, pretend you have a scissors and cut out all 5 sides here and just add them up and add 3 of them and add 5 of them, but whatever. I did it using the formulas. That's easier for me. I did it. It's done. Find the lateral area and surface area of this guy, a cylinder. Now, if you're wondering, well, what's the difference between the two? The lateral area is the area of the sides. Now, imagine if this was like a can of soup, right? And I would cut the top off. I would have myself a circle. If I were to take the sides and kind of like cut it up here, right, and unravel it, I would get myself a rectangle. And if I were to take the bottom and cut the bottom down, I would have another circle. So the lateral area is this rectangle right here. The surface area is the top, the sides, and the bottom. That's the difference. Lateral area is once you sit your shape down the exact way it's supposed to, sit it on top of its base. The lateral area is the area of the sides, and the surface area is the area of everything, sides, top, and bottom. This is a cylinder. So I'm going to split this up into 2 sides so I can find the lateral area, and we'll do the lateral area over here, and then we'll do the surface area over here. The lateral area is found by doing, and it's very similar. If you watch my video for, what did I do, a triangular prism, it's very similar. You could say perimeter times height. So it's the same exact thing, but I know that this is a circumference. Perimeter means circumference, which is 2 pi r height. So instead of saying perimeter height, I'm going to do 2 pi r height. Problem number 1. I'm not given my radius. I'm given my diameter. So I'm going to cross you out and make you a 7. Okay? So, now let's keep the same color. My lateral area is going to be 2 times pi times radius times the height, which was 8. Don't know what that is, so I'm going to go off to the side and ask Siri. So she said 351.8583, so I'll do 351.86 kilometers. This is area, so kilometers squared, that is my lateral area. So if I were to unravel this huge cylinder that is 7 kilometers in radius and 8 kilometers high, a very realistic shape, it would be pretty big. Pretty big. Now I've got surface area, so I'll put SA for surface area. And the surface area now includes the top and the bottom. So without looking up a formula sheet, if it's going to include the top and the bottom, then the surface area, SA, is going to equal 2 pi RH, which is the side, 2 pi RH plus 2 areas of circles. So 2 pi R squareds. So that shouldn't be too crazy to look at. That shouldn't be too wacky to understand. I know part of this already. I know that 2 pi RH is 351.86. 2 times pi r squared is going to be 2 times pi 7 squared. So let me go off to the side. Siri says it's 307.8. 76. So let me add these two together, asking Siri to do it for me. And I get 659.736 kilometers squared. So yeah, I mean, let's just say that you were making like some kind of tower and you needed it to be 8 kilometers high and 14 kilometers long, and you're like, oh man, I wonder how much material I need. You're going to need roughly 659 kilometers of squared of material, which is roughly the size of Rhode Island. Probably not Rhode Island, but like maybe like a city, like maybe like Philly. So a lot. Find the lateral area and surface area of this pentagonal prism. First things first, a lateral area versus the surface area. If I were to take this shape and sit it on its base, which it currently is, the lateral area is just the sides. So these rectangles right here, and all the rectangles are the same, so the lateral area shouldn't be too crazy to do. What is going to be crazy to do is the surface area. We'll get to that. The surface area is, let's add up all 5 sides and the top and the bottom. That's the surface area. So let's find both of them. Let's find out what the lateral area is first. And you find the lateral area of any prism by doing the perimeter of the base times the height of the prism. Now, the perimeter of the base is found by saying, well, look, we have a pentagon, and there's 5 sides. Each side is 12 yards long. So 5 times 12, 60. The height of this prism is 8. So 5 times 12 is 60, and 60 times 8 is 480. And this is yards squared. And again, this makes sense because if I were just to take one of these rectangles, I would get 12, because it's 12 yards long, times 8. I would get, what's 12 times 8? 72, 76, 76, and multiply that by 5. The numbers seem to work out just fine. What's not as fun is the surface area. My SA. I don't have a lot of essays anymore. I have 4 kids. If you're trying to understand that joke, essay is another word for friend. Now, for any prism, your surface area is going to be your lateral area, which is nice because I could just kind of replace that, plus 2 times the area of the base. So far, not so bad. My lateral area, my perimeter of the base times the height was 480. I can handle that. I can handle it just fine, plus 2 times. Now, this is a regular polygon. All right. A regular polygon's area is found by doing 1/2. So times 1/2, that makes life easy, times the apothem. And if you're like, apothem? Isn't that a creature that comes out at night and is ugly and has creepy eyes? No, that's a possum. The apothem is 8.3. It's basically like the radius of a polygon, a regular polygon. So 1/2 times the apothem, which is 1/2 times 8.3, times the perimeter of my polygon, which I already know to be 12 times 5, which is 60. So my surface area is going to be 40 or 480 plus 2 times 1/2. Well, I don't need that anymore. 8.3 times 60. I'm going to go off to the side and figure out what that is. Series says it's 498. Add these two together, and you get 978 yards squared, because area is square yards. There you have it. Pentagonal prism, lateral and surface area. Fun. Find the lateral area and surface area of this pyramid right here. Well, the lateral area of a pyramid is the sides. The surface area is the sides plus your base, your one base. So if you're thinking, oh, this is kind of similar to when they were prisms, kind of, but not exactly the same. Okay, not exactly the same. So let's start out by doing the lateral area first. Okay, the lateral area of any prism is found by doing and I'll put L for lateral area, 1/2 of the perimeter of the base times what is called the slant height. Now, that's a pretty looking L, because that pretty looking L represents the slant height. The slant height is the height of one of the sides if I were to cut this up and kind of stand one of these triangles tall. And if you're thinking, oh, it's basically the height of a triangle, the slant height is the height of the triangle. Okay, so it's very, 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 very similar to 1/2 base times height, which is the area of a triangle. It's just that I'm doing, instead of 1/2 base times height, I'm doing 1/2 perimeter of this whole thing times height of one triangle. Okay, so lots of similarities here. So let's plug in what we have. 1/2 is 1/2. The perimeter is, I have 1, 2, 3. So this is a pentagonal prism. Each side is 8 feet. So the perimeter is going to be 8 times 5, which is 40. The slant height is 10.6. So to find the lateral area, I'm going to do 1/2 times 40 times 10.6, which is 212. Right? Because 20 times, yep. Feet squared, because of area being square units. Now, common sense will tell you that if I'm finding just the sides to give me the lateral area and the only difference is now I have to add my one base, then why don't I write out the formula? I'm not going to go to a formula sheet to find the area of the whole thing, the surface area. Okay, it's going to be my lateral area, which is 1/2 P times slant height plus the area of my one base. All right. So I know that my lateral area is 212. The base is a regular polygon. So you find the base by doing 1/2 times the apothem times the perimeter. And if you're like, apothem? Isn't that an animal that comes out at night and has creepy eyes and sometimes gets hit by my car? No, that's a possum. An apothem is a line connecting the center of a regular polygon to the side of the polygon as long as it creates a 90-degree angle, like a radius, if you will. So my surface area is going to be 212 plus 1/2 times my apothem, which is 5.5, times my perimeter, which I already found out earlier to be 40. Okay, a little bit more math. 212 plus 1/2 times 5.5 times 48, which is 132. And you add these guys together, and that's a 3, and that's a 4, and that's a 4. And this is feet squared. Yeah! Pyramids, Egyptians. Find the lateral area and surface area of this guy right here, which is a cone. I'll tell you one thing right now. I don't like U16 because you're the diameter. I like the radius. I care about radii in this class, friends, and I care about 8. This guy refers to a slant height, the height of the side here. And if you might be thinking, oh man, that means I have to use like what, Pythagorean theorem to find the height of the cone? Maybe. Now, lateral area, what is lateral area? That's the area of just the side of the cone, not the circle on the bottom, just the side of the cone. The formula for the lateral area is pi times r times L. So nothing to do with the height of my cone, thank the Lord. Pi is pi, r is 8, L is 23.4. And I'm going to go off to the side and plug that in my calculator. And I end up getting 588.1061. So I'll do 588.1. Now, the difference between lateral area, oh, by the way, no units. So I'll put units squared. Units squared. It just looks better, even though my handwriting on this problem is kind of sloppy. Now, the difference between lateral area and surface area is the lateral area only cares about the sides. The surface area includes the base. So don't be like, oh, let me look it up. Don't. The surface area is your lateral area, which I already know. So pi r slant height plus the area of one circle. And the area of a circle is pi r squared. So fortunately, I didn't have to worry about the height of this cone at all. I thought I was going to, but didn't. I already know that pi RL is 588.1 plus pi 8 squared, which according to my phone is 9. That can't be right. What's pi times 8 squared? Yeah, that's much better. 201.0619, so I'll do 0.1. And then you add these guys together, and that's what you get. That's what you get when you add them together. Paramore. What's my unit? U. Oh, units squared. See how I made that into a perfect U? Flawless. Gross. Lateral area, surface area, not that much fun. Find the surface area of a sphere. Ugh. Well, the formula is not too bad. The formula for the surface area of a sphere is 4 pi r squared, where r represents the radius which I have. So it's just a calculator exercise. Surface area is going to be 4 times pi times 7 squared, and 4 times pi times 7 squared is 615.7521 centimeters squared. Gross. Dunzo. Find the volume of this guy, a sphere. If you ever took 8th grade math or 7th grade math, you've probably had to do this before, so this isn't super new, and here's the formula for it. Maybe you remembered it, maybe you didn't, but here's problem number 1. This is an R. This is my diameter. So if I take half of it to get my R, half of 15.6 is 7.8. So that's my R. So it's just a calculator exercise. 4/3 times pi times 7.8 cubed. Let me say that again so Siri hears me. 4/3 times pi times 7.8 cubed is 1,987.7987. I'm going with all the digits that Siri gave me. It's inches, so inches cubed. Why cubed? Because this is volume and you do units cubed for volume. All right, volume of a sphere, nothing new, nothing crazy. Are the two figures similar? If so, state the scale factor. Figures are similar if you take all of the corresponding sides, make a fraction out of all of those sides, and the fractions are the same. For example, 12 matches up with 40, so 12 over 40. That has to equal 24 over 80. 24 matches up with 80, so 24 over 80. And looking at this, probably so far so good. And 18 has to match up with 60. So divide by 4, so that's 3 over 10. Divide by 4, I could divide by 8 and divide by 8, and that's also 3 over 10. And divide by 6, and that's 3 over 10. So the nice thing about doing it this way is we get a big fat yes for this one. And not only do we get a yes, this gives me my scale factor from small to big. So we can write it out as 3 to 10. I believe more often than not, they want you to do small to big when they ask you for scale factor. I know or they want you to go from left to right. So left to right here would be 3 to 10. Either way, it will probably be specific. And if it's not, always go left to right or top to bottom or just say what it is. But yes, 3 to 10, that's that guy. Since I have a whole lot of congruent stuff going on here, I don't have to worry so much. 18 matches up with 54, so I'll do 18 over 54. That's got to match up with 6 over 21. Okay. 18 and 54, I can divide them both by 9, and that I can divide them both by 18. And that gets me 1/3. 6 over 21 is, I can divide you by 3. I can divide you by 3. 2 over 7. No, these aren't similar. These aren't similar at all. Shame. But that's how you do it. Very similar to if you have flat shapes. If you have 2D shapes, you just have to do a few more things if you want to do 3D shapes. Find the missing value. All right, I've got two solids, no picture. I've got the surface area of solid 1 and the surface area of solid 2. I have the volume of solid 1, no volume for solid 2. This guy, bigger than that guy, big, small. Now, these are similar figures, so I'm thinking ratio thoughts. But I can't this can't be just easy. All right, I'm going to compare the volume to the surface area. And the way that I'm going to do that is I'm going to create ratios of big to small figures. In other words, the volume on the big solid is 1, 3, 3, 1, 2, and the volume on the small solid is, I don't know, call it X. The surface area on the big guy is 1088, and the surface area on the small guy is 425. Now, we can't just end here. We are now saying that volume is equal to surface area. No, it's not. If you want to break down volume and surface area to its simplest, most regular length, I would have to cube root volume and square root surface area in order to get these guys equal to each other. So similarly, I have to cube root that guy and square root that guy in order to get things equal to each other. All right. So the left side doesn't change. I have a big cube root 1, 3, 3, 1, 2 over X, too much line. Okay. 1088 divided by 425 is 2.56. Now that's good because when I write it up here, the cube root, again, I'm not changing anything here, 13,312 over X. That's going to equal the square root of 2.56, I believe is 1.6. It is 1.6. I use Siri. I secretly use Siri. Now this cube root's just in the way. How do I get rid of a cube root? Cube everything. Mark cubing. That cancels things out. Cancel, cancel. Now I have 13,312 over X is going to equal 1.6 cubed, which is 4.096. Why did you write that all the way up there? So I can put it over 1 and make it a ratio, and now I can do crisscross applesauce. So I am going to do crisscross applesauce. 4.096x equals 13,312. Divide both sides by 4.096. And 13,312 divided by 4.096 is 3,250. Now my goal was to find the volume, kilometers, so kilometers cubed. These problems are not pleasant in any way whatsoever, at all, ever, on the planet, ever, at all. But we did it, and I feel good.